Hi, Atluma. Thanks so much for your question. Now let's start with question number 1. So basically what they want us to do here is calculate for A and show that AE is equal to AF. Now in this case, what we're going to do is try and solve for A using that 2A that they've given us here and using that line that has been extended to D. Now the reason why they've extended that line is because they want us to note that line at A is 180 degrees because those two angles are supplementary. So this is what we're going to do first. We're going to write here 5A minus 40 plus B is equal to 180 degrees. Now you can either write supplementary angles or you can write angles on a straight line. Remember, we have to give reasons for all of these. Angles on a straight line. Therefore, what we're going to get for B, which is inside the triangle, is B is going to equal to 180 degrees minus 5A plus 40 degrees. Now we can rewrite B. This is going to be equal to 220 degrees minus 5A. Now we can use this information we've got here and plug that into what you've written in your answer, where we can say in triangle AFE, we're going to get B plus 2A plus 80 degrees, which is going to equal to 180 degrees. And our reason here is angles of a triangle. Now we can replace B with what we've gotten here for B in the first part. So we're going to get 220 degrees minus 5A plus 2A plus 80 degrees is equal to 180 degrees. And then we can just make A the subject of the formula here. So what we're going to get here is negative 3A is equal to, then we're going to have 180 degrees minus 220 degrees minus 80 degrees. And if we put all of that together, negative 3A is going to give us negative 120 degrees. And if we divide both sides by negative 3, we're going to get that A is equal to 40 degrees. And then we can plug that back into what we know. So now we know that A is equal to 40 degrees. Therefore, we can go angle E is equal to 2A, which is equal to 2 multiplied by 40 degrees, which is equal to 80 degrees. Now this is very helpful because that means that this triangle, therefore, triangle AFE is an isosceles. Isosceles. There we go. And that means we know that the properties of a isosceles triangle tells us that AF will then be equal to AE. Okay, and this is how we can solve for that first part. And now we can then use what we have to solve for B and for D and for E. We'll do that in the next part. Now to solve for number 2, okay, we've already figured out what A is, so we can use what we know about A to solve for B. So we can say B is equal to, well, you can either use 220 minus 5A, which we can do in this case because we know that A is now 40 degrees. We can use 220 minus 5 multiplied by 40 degrees. And this is going to equal to 220 degrees minus 200 degrees. Therefore, B is equal to 20 degrees. Okay, and we've used all the properties we've just figured out for A. Now, if we have to solve for C, you'll note that because EF is parallel to BC, then we can use the properties of corresponding angles, alternate angles, and co-interior angles. So in this case, because AB is a straight line, we know that 2A is going to equal to C. The reason for that, because they are corresponding angles. Therefore, we know that 2A is going to be 40 degrees, 2 multiplied by 40 degrees, which is equal to C. Therefore, that is equal to C is equal to 80 degrees. And that's how we solve for C. Now, to solve for D, you'll see that F there is a straight line. So in order to solve for D, we're going to say that D is equal to 180 degrees minus 80 degrees, because we've got two angles on a straight line. A straight, STR stands for straight line. And therefore, D will then be equal to 100 degrees. There we go. And to solve for E, we can do exactly what we did with C as well. So we can just say E, okay, is going to be equal to 80 degrees. That reason is because we have two corresponding angles. Okay, and that's how we solve for all of those. I hope this was helpful. If you need any more help, please don't hesitate to ask. All the best.